Hi to all. Now we are going to see the common rail direct injection system. This is called CRDI engine. Now see, this is the overall picture of a common rail direct injection system. Common rail means, see here, this is the one where which we are total fuel will be pressurized and then we are sending to the main engines. So normally these common rail direct injection systems will have a fuel tank, fuel filters, and then high pressurized fuel pump, which will be sending to the common rail. This is a common rail. So from there, this that will be to the injectors. Here, this is the injector. So these are the common components which will be attached, and then normally this is will be controlled by the ECU. ECU means electronics engine control management systems. Now next, what is CRD engine? So modern diesel engines have a popularity to advance the fuel delivery and the engine management systems that allows the engine return to power, performance and emissions equivalent to the gasoline engine. So a diesel engine systems which have a common pressure accumulator called rail, which is mounted along the engine block. So now see here, is it applicable only for diesel engine? No, it is also applicable in the gasoline engine, where we call it as a GDI, means gasoline direct injection, or normally fuel stratified injection systems. These technology have a similar design since they consist of a fuel rail that supply the fuel injections. So, however, they considerably differ on parameters such as system pressure and the types of. Now the deficiency, the normal conventional diesel engine, why we need this is sluggish, noisy and poor in performance, and the exhaust gas emissions. So we can improve the exhaust gas emissions also. So common rail injection systems, there are four basic components. Okay, one is the high pressure fuel pump. This is the number one. This is the high pressure fuel pump. Second one is the common rail. This is a common rail where which it build up the pressure, increasing the pressure. From there it is going to the injector. Here it is an injector. So now see here it is a ECU, means it is controlling through all the sensors, through the electronics control engine electronic control units. It is sensing how much amount of fuel will be passed to a particular injectors. Now let us see the construction and working principles. Okay, so already we have seen in the first diagram itself how all the four ports are. Okay, it is connected. It is a high pressure fuel rail, the computer controlled electronics injectors that make all the differences. So the common rail, the fuel pump charges the fuel rail at a pressure of 25,000 psi. So normal fuel injector systems we may increase to from 200 psi to 200 psi to maybe 200 psi to the up to 2000. Now we are increased to 25,000 psi. Under the control of onboard computers, this fuel quantity and the pressure accumulates the rail independently of engine speed and load. So each fuel injector is mounted directly above the piston of above inside the engine within the cylinder head, and it is connected to rail by a rigid steel pipelines. So this high pressure allows very fine injector orifice that completely atomize the fuel and precludes the need of a pre-chambers. The actuation of the injectors comes via a stack piezoelectric crystal wafers that move the jet nozzle in a tiny increments, allowing for a fuel spray. The injectors are controlled by the engine computers and can be fired in rapid session in several times during the injection. With this precious control over the injectors firing, smaller staggering quantities of fuel delivery can be timed over the course of the power stroke to promote complete accurate combustion. In addition to the timing of control, the short duration, high pressure injections allows a finer and more accurate spray of pattern that also supports the better and more complete automation and combustion. Furthermore, the ECU, now the role of ECUs to get inputs from various sensors, it then calculate the precise quantity of fuel and the timing of the injections. So the sensors may be placed in different wherever these parameters is which controlling the it's supposed to control like from accelerator. How much oscillator it is we are going to increase or decreasing that oscillator sensors will senses it and accordingly it allow. Likewise the oxygen sensors and other sensors which is uh, sense what is the amount of fuel is required, that will be regulated by this ECU. As a result, this fuel system more intelligent component in nature. In addition to the more advanced and electrically operated solenoid injectors replace the conventional injectors and an ECU signals them. So it depends upon the engine speed, load, engine temperatures and other parameters which is required to control the fuel. Now there are various manufacturers, four-wheelers manufacturers. They are named these uh, CRDI engines in different forms, which you might have seen it's in the backside of an vehicles. You can see like Mercedes mentioned, they will mention it as a CRDI capital S. Okay, Honda CRDI, CR4 CRD. Likewise, they are mentioned. Here also other there are Volkswagen, Ford, Seravolt, Fiat, Honda. All these they are how they are. Now, what are the advantages? CRD engines produce more power and torque. This engine has the ability to increase the engine power and torque by 35%. This technology increases the efficiency of an engine, so it decreases the tailpipe emissions. It also decreases the noise and vibration on the engine. The disadvantages is high cost. The technology is not applicable to all type of engines. The cost of maintenance of CRDA engine is high. The cost of spare parts is also high. Thank you.